from Oil India Limited, Duliajan, Assam, application for floating pump suction system for suction lift pumping from river, a case study. Yeah, you are welcome to present your case study. You are Mr. Das, right? Das?
Yes.
And Gogoi is also there. Will you be also presenting?
No.
Only Gogoi, only you will be presenting.
Yes, so EEP for giving us this opportunity to present a small case study that was encountered by us in our day-to-day working in Oil India Limited. Myself, Chandan Kumar Das, and my colleague Manoj Kumar Gogoi is also there. So this is a very, as the theme of the seminar is harnessing employees' creativity for enhancing safety and business performance improvement. We are presenting before you a small case study based on how a small creativity, or we can say that innovation, can go a long way in providing the requisite output in a real life working scenario. So ours is Oil India Limited. It was incorporated in 1959 and nationalized in 1981, and presently it's a Navratna PSU. So Oil India is having national as well as international presence in northeastern region, Rajasthan, Ganga Valley, Manali also, Krishna Godavari Basin. We also hold 80.16% equity in Numaligarh Refinery Limited, and we are having international presence in Venezuela, Gabon, Iran, Nigeria, Timor, Sudan, etc. So, being an EMP company, that is an exploration and production company of crude oil and natural gas, our business is to drill into underground reservoirs for hydrocarbons, for exploration of hydrocarbons. Usually, after completion of a well, drilling of a well, the reservoirs have natural pressure which enables the hydrocarbon to flow to the surface on their own. While the nation was recuperating from this COVID-19 epidemic during summer 2020, a producing well of oil started to release natural gas uncontrollably from the wellhead. In oil field parlance, it is called as the blowout. It's a catastrophic happening for an EMP company. So our aim was how to control the blowout immediately, and another byproduct of a blowout is a very fatal chances there of the oil getting fired. So our immediate challenge was to control the blowout. On the other hand, it was also to provision for sufficient amount of water so that the well can be cooled and well doesn't get fired. However, in spite of our best efforts, the well caught fire. So this is a side picture of the well. So our team was entrusted with the responsibility to source, maintain and establish, source and maintain a diluent water system. Diluent water system is a firefighting water system which is required for any blowout control system or any fire protection system. So, and to ensure the safe well control activities, we had to source at least 8,000 to 10,000 GPM of diluent water pumping system. So, in the meantime, ONGC's crisis management team was also called in for support our activities, and some international experts who were expert in well control, they were also called in. So, to source the diluent water system, this is the blowout site. From this blowout site, at around 800 meters to 1 kilometer, there is a river. The river is a tributary of the mighty river Brahmaputra. So, one typical issue with the river, it's a very, the river is changing its, water source very rapidly, even during a day. So there were logistical issues as the roads were kacha and proper equipment, mobilization of proper equipment to the site was very difficult for us. Then since this was a very temporary nature job, all the pump sets for sourcing diluted water system had to be installed on a very temporary basis, like on sandbags or porta deck mats. Then the major challenge was the fluctuating river water level. This was the most critical challenge encountered by us while installing the diluted water pump sets. Depending on the weather conditions, the water level in the river used to change drastically, or rather I can say fluctuate drastically up to a range of up to approximately 3 meters. It is shown pictorially here. Say in the morning, the river water level is here. We have installed a foot valve with a metallic pipe for taking suction from the river. Then in the evening, you can see the river water level recedes below to the foot valve, so making this whole arrangement redundant or useless. So conventionally, to counter this sort of fluctuating river water levels or to extract pump water from a river, floating barges or pontoon boats are used. But in our case, availability of such boats were not feasible. So all hired 2 number boats and 4 number DET diesel engine driven pump sets were installed on the boats. However, to meet the diluted water volume requirement, the pump sets installed on the boats on the river was not sufficient. So we had to install another additional 3 pumps to meet to the diluted water volume requirement. So our team was looking for solutions to how to negate the counter the fluctuating river water levels. Then an innovation came to our mind that why not let the suction itself is why not make the suction floating on the river water itself, rather than going for a boat. We'll place the pump on the river bank and make the suction floating on the river water. So we tried to design and fabricate a floating platform to accommodate the pump foot valve and to accommodate for the fluctuating river water levels. We have replaced one portion of the steel pump suction piping with a flexible rubber hose pipe, so that rubber hose pipe will accommodate the fluctuating river water levels and it will come up and down with the floating platform. So it was designed and fabricated in-house. So this pictorially shown, this was a platform, very basic sort of infrastructure with some 200 liter capacity drums. We had fabricated a floating platform like this, and the foot valve was installed here, and this is the rubber hose pipe you can see. This is the full assembly. This is the foot valve. This is the flexible rubber piping to accommodate the river water, fluctuating river water levels. And finally, this is the complete installation you can see. This is the river, this is the floating platform, this is the centrifugal pump which is installed on the river bank, and this is the complete floating pump suction system. So what we can conclude, it's a very simple innovation. You all can see there's nothing very highly technical out here, but using this system in that critical scenario like a blowout and in case of a very huge catastrophic disaster that struck in our organization, with this very small innovation we can sustain the requirement of the diluted water requirement system for the load control activities. So we can say that any innovations which may be a very small or seem like not very highly technical, but it can go a very long way in helping the organization to achieve its required goals. So the ONGC people, the ONGC crisis management team was also helping our organization in the well control activities. So when they saw this floating suction system, they also insisted that their pumps should be also fitted with such floating suction systems, and we are happy to say that we managed to fabricate and install same system for their pumps also. So this is our acknowledgement for our risk management and the group associated with the innovation job. Thank you, sir.
So early? I think we can have a very long lunch break. Questions, please. So no question? No questions, sir. Yeah, you have, please.
So this innovation what you have shown here. So I think this is the in-house innovation what you have said. So what is the estimated cost for this particular thing?
Estimated cost. Drums are usually we would have stepped those drums. So drums are, you can say it is costing zero, and some small 1-inch pipes were used. For the entire set of 8 numbers, I can say the material cost will be less than 1 lakh.
And what is the basically the outcome what you have said? Can you just elaborate on the outcome?
Outcome is what I'm happy to say that it is not a very hi-fi or any highly technical innovation. It's a very small kind of innovation. But any innovation, whatever sort of innovation, how small it may look, but it can go a long way in sustaining the organization's goal, and its its innovation can play a very active role in supporting the organization. It was a very crisis situation and catastrophic incident had occurred in our organization. So this innovation has enabled us to sustain the release water system so that the well control activities could go on very smoothly.
So was there any incident happened and because of that only this trigger was there to look into this kind of innovation?
Pardon, sir?
Was there any incident or accident by which the trigger for having mobilization of this particular innovation?
Actually, sir, the total water requirement was around 8,000 to 10,000 GPMs per day. So, to sustain that, to pump water from the river, we managed 2 boats to be used as pontoon barges. On those 2 boats, we installed 4 numbers pumps, but those pumps were also not sufficient to meet the requirement. So we had to install another 3 pumps. So to install another 3 pumps, there were no boats available, and moreover, space concern was there, so that in the river also we could not install those boats. So we had to install the pumps on the river bank itself. We were forced to install the pumps on the river bank. But since the river water level was fluctuating so much, so we had to think for a out-of-box solution.
Yeah.
See, you repeatedly telling innovation, small innovation, not good. Innovation and creativity, it cannot be measured in terms of big and small, technical, non-technical. It is a creativity, it is a innovation. Because by doing this, you have saved a lot of other safety problems.
Yes.
Because the water was not available, then so many things would have happened. So the value of that innovation is not in terms of how much money you spend, how much efforts you have taken. It is the outcome of that. So it is very, whosoever has thought about that idea of putting that floating platform by using the whatever material available there and able to get the required result. So that's nice. Thank you.
Thank you.